I think I should be joined soon by the folks here at the Building Centre who will adjust the lights for us. But yeah, thank you so much to everyone for coming. This is one of our series of events as part of the Retrofit 25 series. We're going to be talking today about carbon and materials. Now, this is a topic that's really dear to my heart. It was one of the sort of entry points for me getting into sustainability and climate change in the built environment. Back in 2020, I was part of a group within the Architects Climate Action Network that was campaigning for the regulation of embodied carbon, and we did lots of research and we released this paper exploring the case for regulation, how you might go about it, what the examples might be. And since then, calls from the industry have really grown to make more of an effort to mitigate embodied carbon and ecological impacts. We've got campaigns like Part Z and Don't Waste Buildings. And a lot of them really highlight the role that retrofit plays in reducing carbon emissions and prioritising retrofit as a strategy in itself to make sure we keep within planetary boundaries. Now, while retrofit is much less carbon intensive usually than new build, we must still consider the whole life carbon of retrofit projects and solutions without focusing on maybe local materials, low carbon, circular strategies, and optimization strategies. Retrofit might fall short of meeting both climate goals and the needs for future generations. Now, we know that the benefits of retrofit extend well beyond reductions in operational energy use. And when executed well, retrofit can really lead to improvements in the longevity, in the quality, in the health of our buildings, enhancing the lives of people who live within them. But everything we do in construction has an impact, and it's crucial that we understand the various positive, neutral, and negative impacts so that we can make really good quality, holistic decisions. There's space in this for both big innovation and the improvement and optimization of existing approaches. The circular economy, efficiency in design, local sourcing, natural materials, and material innovation all play a role. And today you'll hear from a wide variety of solutions from those leading positive change. I always forget to introduce myself. I'm Rachael Owens, I'm co-director of the National Retrofit Hub. We're one of the curators of the exhibition alongside the Building Centre. And yeah, really happy that you could all join us today. So I'm going to be joined today by John Ferguson, CEO of Sisaltech, by Premma Makanji, who's Associate at Eckersley O'Callaghan, Gareth Morris, who's Head of Construction Services at Saint-Gobain, Dr. Robert Grover, who's Senior Lecturer at the University of Bath, and Victoria Podmore, Operations and Compliance Manager at EWI Pro. There's going to be time at the end for questions, so please do have a think as we go along. And I'm going to hand now over to John. So over to you, John. And there's a...
Thank you very much. Hi everyone, good evening. I'm John Ferguson, founder and CEO of Sisaltech. We use natural and recycled fibres to make sustainable insulation products. So to kind of start at the beginning, obviously we're dealing with a climate emergency, and the framework that the UK government is kind of dealing with this is, you know, within net zero. And I suppose good progress has been made in certain areas, like in terms of renewable energy. Progress has been amazing. And in terms of the kind of transition to electric vehicles, that's pretty well underway. But it's kind of like our building stock in the UK is kind of like the last kind of big piece of the jigsaw puzzle. So most buildings are still being heated by burning fossil fuels, and a lot of that heat is just going straight out the roof. So clearly there needs to be a lot of insulating. Insulation on the face of it doesn't sound like very sexy or very exciting, but in fact it's got like a really key and vital role to play in tackling the climate emergency. This is quite an interesting little slide where basically it shows heat loss from average buildings in different countries over half a day. I think they heat the building up to 20 degrees when it's 0 degrees outside, and then switch off the heating and see how long it takes or see how much temperature drops over that period. So you can see that the UK, an average building in the UK, has the biggest average temperature loss of anywhere in Europe, basically, 3 times that of Norway. And what is the reason for that? It's because we have a lot of amazing, beautiful, historically significant buildings that you probably don't want to just be plastering all over the outside of it with external insulation. So these have been kind of historically known as hard to heat or hard to treat buildings. I'm not sure that they necessarily are, but more work needs to be done in that field. So if we come to kind of focus on insulation for a minute, we've already said lots of insulating needs to be done. So we're now kind of talking about, okay, if you're going to do lots of insulating, what materials do you want to use to do that? And a lot of the mainstream insulation products at the moment are synthetic. So they're either based on oil or they're very carbon intensive to produce. They typically tend to be very itchy and unpleasant to work with. It's quite, when you think about it, it's quite unusual for there to be a kind of category of products that all of the main ones are accepted as being horrible to work with, but that kind of is the case with insulation. As houses and buildings become more and more airtight to Passive House standard and so on, off-gassing becomes more of an issue. So in your kind of PIR type foams, often over time, they release pretty nasty chemicals. And then, yeah, end-of-life considerations. And in terms of the stone buildings, the kind of traditional stone buildings that, you know, I just had a photo of there, they're really not suited. You really don't want to be putting impervious plastic-based product up against, you know, a natural stone building, or you'll have all kinds of breathability issues. So our particular solution, our product is called Sisal wool. We use a blend of sheep's wool and sisal fibre, which is a plant fibre. Sheep's wool insulation already exists, but it tends to be quite soft and floppy, so only really suitable for use in attics. But by combining it with sisal fibre, which is a very stiff and rigid plant fibre, we end up with a product with a much better kind of structure, which means it can be used in a wider variety of applications, so like in pitched roofs, in walls, under suspended timber floors, and so on. And actually, all of or the majority of our fibres are recycled. So we get waste wool from the English carpet making industry and from the Harris tweed industry. And we get most of our sisal fibre from recycling coffee sacks. So we gather in coffee sacks from coffee roasters, sort them out into different categories, and the sisal ones we shred and use in our product. Even our binder is also a recycled binder as well. I probably don't have time to go into all the performance benefits. I'll show you some pretty pictures instead. So this is just kind of a typical example of retrofitting, where somebody would take off the lath and plaster and go back to the bare stone, sometimes leaving the original timbers there and fitting insulation in between, or sometimes building them out or replacing. It's a good little example there, and our product is really designed so it can be squeezed just enough to get a really tight friction fit. There's a whole other area that we could talk about here about the performance gap between the difference between the kind of quoted thermal performance on paper and the real world performance that you get. But what quite often happens with retrofitting is that the timbers are not straight and perfect like they would be in a new build. So having a product that's kind of semi-flexible and can accommodate those imperfections will actually result in a better real-world performance than something like a rigid PIR foam, which on paper looks great, but in reality might not be. Just more pretty pictures, basically, because we like our product. It's an attic being fitted out with sisal wool. And this is a historic building in the centre of Edinburgh called the Witchery, which is right on the Royal Mile next to Edinburgh Castle. The owners wanted to be really confident that they were not going to be damaging the building when they started insulating, so you can see basically just where they're stripping out on the pitched roof to try and improve thermal performance whilst keeping the kind of the characteristics of the building. And this is just a little bit about our company. Or obviously we kind of we exist to help tackle the climate emergency, and the way that we do that is by trying to develop products that builders, tradesmen, architects can specify and use in a kind of similar way that they would with mainstream insulation products, to try and make the switch basically as easy as possible for them. And there, I think I've finished ahead of time.
Amazing. Thank you so much, John. And you are perfectly on time. I'm going to hand over now to Premma.
Great. Hi, everyone. I'm Premma Makanji. I'm an associate structural engineer at Eckersley O'Callaghan, focusing mostly on refurbishment projects and sometimes listed buildings as well. A bit about EOC. We are a company of about 150 engineers who are spread across 8 offices globally. About 2/3 of those are in London. This is our kind of mission. We're passionate about designing great buildings and enabling a sustainable built environment. What we do is structural and facade engineering. Just going to rush through this quite quickly, but this is kind of the range of projects that we work on. You'll see there kind of a variety of scales and different sectors. And also we work with kind of a wide range of materials, so from the kind of natural and bio-based, for example, timber and stone, but all the way to like engineered and novel materials like glass and acrylic. So these are kind of 3 of our focus areas: sustainability, digital design, research and innovation. And we think that the kind of future of engineering and construction is where these 3 areas meet, and we've been working on some tools that bring these focus areas together. This is a bit of a kind of step back. So this is kind of a graphic from the Institution of Structural Engineers, and it's about whole life carbon. So recently there's been quite a bit of success in regulating energy efficiency by which reduces operational carbon emissions. And in the future, we'll be decarbonising the grid, which means there's going to be greater impact from embodied carbon. So this means there's a shift in the importance to structural engineering as engineers specify many of the materials that are going into buildings. So we were thinking about that, and we started to look at reducing embodied carbon in terms of our projects. And we thought that it's at concept stage where we've got the greatest ability to make changes and add value to the design without significantly impacting the cost of the project or the environment. So we've made 3 tools. So 2 of them are based on the early design stages where we need to rapidly explore different options, and 1 is based on the later design stages when a detailed design already exists. So these are the 3 tools. The first one is the smart massing tool, which is made on Rhino and Grasshopper. And what it does is you can put in the geometry of your building, and you can change the structural grid and the frame, and it will calculate the embodied carbon in real time. And then this is a bit about how it works, which is quite easy to show in a video, but basically you can set the shape of your building, set the grid, you can rotate the grid, you can make different bays different sizes, you can see what impact that has on the foundations by adding different number of stories. You can also change the materiality. And we think this helps us to influence the materiality and the grid at an early stage of the design. So the next tool is the Bay Builder, which is very similar to the smart massing tool, but it's for facades. So in a similar way, you can change the kind of bay size and the inner and outer skin of your wall, the type of insulation, and the size and shape of the window. And again, you can see in real time what that does to the embodied carbon and also the U value. And it works also for glazed elevations with different kind of size of infills or rain screens. Then the final tool, which is for the advanced design stages, is basically just a Revit plugin. So you would have your structural model, and then you would open the plugin, and it's calculated lots of, so each of your areas is put in, and you can select them, and then it calculates the volume and the density of that material, and then you can assign them a material, and it goes to the database to pull the embodied carbon from there, so then it can calculate the embodied carbon for the whole building. And the main thing to say about this tool is that EOC have made this open source, and it's already been downloaded by about 150 companies worldwide. So on the back of that, we decided that we would calculate embodied carbon on all of our projects. So we've had a look at what the data has told us so far. So these are our projects that we've calculated embodied carbon for over the last sort of 10 years. In each dot represents a project, and the vertical scale is the embodied carbon. And then the yellow and green lines are the rating from the Institute of Structural Engineers called the scores rating, which comes from the LETI targets. And as you can see, the dots are quite widely dispersed. However, the grey line is the trend, and it's sort of on a gradual downward slope. But if we're going to reach net zero in 2050, then we need a much sharper trajectory. So we also plotted all of our projects in terms of size, and also the orange dot is refurbishment and grey is new build. And you can see that it's mostly refurbishment projects that meet the scores rating A. And above that, you have some projects that are refurbishments that have quite a high embodied carbon. And looking into those, a lot of them have basements or large areas of floor that are being replaced. And sometimes quite a lot of load-bearing walls, which are then also included in our model. And then the final graph from that is that all our projects in order. So the main thing that you can see there is that the refurbishment projects have the lowest embodied carbon, but after that, it's the timber ones which score the next lowest. So it was clear to us that we need to be doing more refurbishment. So we've sort of thought about how we can do more refurbishment. So we've put together some case studies that are kind of varying in scale, and typically not buildings that you would consider to be like super glamorous and not listed. And this is the kind of like hierarchy for net zero structural design. So the first one is a project that we're doing at Quentin Blake Centre for Illustration. And it's a building that was originally a storage building. It's not particularly high quality. It's actually not in. It's suffered a lot because there are trees directly adjacent to the building that have affected the walls and the entire ground floor slab. On top of that, the roof structure is not very consistent. It's been adapted over time when leaks have come in. So our original design, so the architect wanted to put a two-storey building there, and our original design was to replace that building and put a new steel frame on a kind of piled foundation. However, due to costs, we were asked to review retaining the existing building. So we had to take a step back and look at the drivers behind why we were replacing the building, and the main one was the fact that the adjacency to trees were causing movement. So in that point, we worked with the client to directly discuss with them the implications in keeping existing, and that was going to be that there'd be some like minor cracking in the future, and possibly some needing to replace like thresholds. So once they understood those kind of parameters, they were able to accept that. So we moved towards a timber frame. So we built a new timber frame internally, and we were using whichever trusses we could and moving them up to the roof. On top of that, we put in a kind of Victorian-style raised timber ground floor. So that dealt with the bulk of the movement, but not all of it. And this is kind of just a basic example about how you can work with the client to kind of help them understand the engineering parameters, and that means that you can deviate from a kind of standard engineering approach and ultimately kind of make quite a large cost saving as well as a large embodied carbon saving. The next project is our project at London South Bank University. So this is an existing building from the 1970s. It was used as teaching and office space and had quite a cellular layout. And the proposal was to change that into a student hub with more of an open plan layout. And the intention was to retain existing. The structure itself was a concrete frame with waffle slabs. So our first, the main thing that we did was fully understand everything there was to understand about the structure. So we knew that where there was capacity and where there wasn't capacity. So for example, nearly all the floors were okay, but then a few areas where we were increasing loads, such as plant rooms, we added carbon fibre strengthening to the underside of the slab. And then the other main intervention was that the existing light wells of the building were to be infilled. And we knew that the structure surrounding the light wells didn't have very much capacity, but the columns did. So we spanned the new structure between existing columns at roof level, and then we hung the floors from that structure, which meant that we could take all the load onto the columns and avoid strengthening the foundations. So the outcome of that project is that you can see it's got an embodied carbon of 49 kilograms of CO2e per metre squared, which is about 5 to 6 times less than an equivalent new build. Then the next project is at Magdalen College, is an existing student accommodation, which isn't widely loved by the public as a building. So we were brought onto this project at feasibility stage. On this project, we had very slim archive material. So in this instance, we kind of surveyed the building and helped the architect understand what existing was. So we gave them column locations, downstand beam sizes, thicknesses of slabs. We also used our benchmarking information to tell them what the embodied carbon would be for new build or refurb. And the outcome of this project was that actually the existing building couldn't be retained because the floor-to-ceiling heights were too low and the downstand beams were too detrimental to the servicing strategy. However, in that instance, the footprint of the new building and the existing building was quite similar, so we wanted to have reuse in some form. So we proposed a kind of transfer slab at first floor, which meant that the kind of column locations above could be transferred to the existing column locations below. Then we also proposed building above in timber, so we could do a greater number of stories. And then we could also keep the load within the existing, so that meant we could keep the existing foundations and the existing basement. And then I think I'm running out of time, so I'm just going to flick through this, but this is just a project where we use the smart massing tool to come up with an array of options at feasibility stage to help everyone make meaningful comparisons. I'm just going to leave that. Okay.
That was amazing. Really cool to see how the tools are used at that early stage and then how you continue the design thinking after that. And as an architect by background, I would love to spend lots of time with you playing with those tools, and I'm sure many in the room would as well. We're going to hand over now to Gareth. Over to you.
Right, good evening everyone. Gareth Morris, Head of Construction Services for Saint-Gobain UK. Basically, I look after a technical services team within Saint-Gobain across all of our businesses. We look after things like life cycle assessment, circular economy and building physics services. We use it internally within our business, but also dish that out to some of our customers as well. Just to give you an idea of the business, I'll just give you a really quick run through of who we are and what we do. We're a very large global construction product manufacturer, something like 50 billion euros a year revenue, 160,000 employees, and I think we're in 80 countries now. But I think that's not a boasting figure, but it's tried to get across the point that it's really important for businesses like ours to be focusing on the embodied carbon of our construction products just because of the vast quantity that we're manufacturing. We produce products in all sectors really for construction, new lightweight construction, energy efficient renovations, and we have a construction chemicals business which looks at how to decarbonise things like concrete and cement. You'll be familiar with probably a number of these businesses, and I think it always surprised me when I joined the group what's in Saint-Gobain, and you start seeing brands like British Gypsum, Weber, Isova. If any of you worked on retrofit projects, I'd be very surprised if none of our products have ended up in your project, either on purpose or by accident. Our core focus is really about light and sustainable construction. So we're trying to move much more as a collective business now, instead of a bunch of individual, very large businesses in their own right. How do we bring to the market solutions which combine materials from a number of our different businesses, all following the same ethos around lower embodied carbon, circularity, etc. And we're really driving to reduce emissions, resource consumption, make things easier to dismantle and recover, deliver better health and comfort for building users as well as in people installing, and deliver on construction savings, including time and cost. We've got some core objectives around sustainability, so typical carbon reductions across scope 1, 2 and 3 as you'd expect, but massive reductions around our use of virgin raw materials and a drive to develop LCAs for everything that we manufacture by 2030. I'm sure many of you in the room use EPDs. That's my team's job. Problem is we've got tens of thousands of products to make them for, so we can't do that quite quickly enough. I know I've got a job for 5 more years at least. I want to touch a little bit on some of our history around retrofit. I mean, I've got 7 minutes. I know that I could have talked for a long while around the activity of all of our businesses on this topic. But we've engaged with retrofit for a long time. I don't know if any of you are familiar with the University of Salford's Energy House project. 10, 12 years ago, I think this was, we put a Victorian home in a climate chamber which can run temperatures of -10, +20, mimic wind, snow and rain. And that was really all about testing fabric solutions, fabric improvements for the building, the wall, the roofs, the floors, the windows and doors. Is it stage retrofit? Does it matter if you do it in bits? Should you do it all in one go? What are the potential unintended consequences of not doing this properly? So there's a lot of research around operational performance at that point, and as Premma quite nicely touched on, we kind of know how to deal with operational carbon in retrofit. It's more now a case of how do we deal with embodied carbon. It's also not a Saint-Gobain presentation if we don't touch on eHome 2, which is the new Salford University chamber, which is just a more advanced version, but we've built an off-site manufactured timber frame home in there, and there's a new life cycle assessment study looking at that building versus traditional construction due out tomorrow, actually, so there's some nice reading there. But I'll get off the non-retrofit stuff. I just want to talk about some of our initiatives around circularity and reduced embodied carbon. So on LCA, I mean, a lot of the time we produce them for EPDs because our customers and their design teams, the industry, demand them to understand the embodied carbon of their buildings. Often my team will create them and our marketing and sales guys will have a little party and I'll say, actually, this is where the work begins now. How do we use this thing to help us drive impact out of the products that we manufacture? Measuring is just the beginning. Our glass business have been doing some great work over the last few years in circularity. So renovation, for many years, we've been really good at recovering any resources from our own production processes and further down in the supply chain. That's not just glass, we do that in plasterboard and insulation as well. But in the last 3 to 4 years, they've really mastered the art of recovering glass from large buildings being renovated. So particularly in and around London. We've invested heavily in a recycling centre at our site up in Yorkshire, and we've been recovering steadily more and more material from more and more projects over time. Premma, I'm sure Eckersley O'Callaghan on your facades work will have engaged with our glass business, but really, this is how circularity can really help us drive CO2 out of our products. You know, traditionally we'd be melting sand at very high temperatures in a furnace to produce glass. We're now recovering glass, which melts at a much lower temperature, less CO2, less embodied carbon in the material, win-win for everybody. What's really nice that's emerging out of this as well around glass is that if there are certain types of glass, coloured glass, or perhaps stuff with films on it, which we can't put back into our furnace to produce new, clear, nice glass. But we do have other businesses like our glass wool insulation business and our renders business who can then sort of leach off the stuff that glass don't want, if you like, and begin to put that in as fillers or as raw materials for their own production processes. So like an industrial symbiosis, if you like, across our collection of businesses. There's a couple of other materials that we've launched over the last couple of years. British Gypsum launched recently 100% recycled gypsum plasterboard. That's new to the market this year. Natalie will probably tell you the date better than I can, but we can make that now. And it's really a case of now that we know we can produce materials with recycled gypsum powder, how do we improve the business model? How do we improve the process of recycling gypsum? Because we've become so good at mining it, how do we now switch to a lower embodied carbon, more efficient process to recycle? I think there's a system upstairs in the exhibition called Weber Wall, which is like a really thin brick slip effect finish that would be typically suited for EWI. That's featured on our LCA for the Salford eHome 2 project, which sort of shows quite significant reductions if you compare this kind of facade versus brick. Yes, it doesn't perhaps deliver some of the same functionality of brickwork, but we're looking for more light, easy to install, lower embodied carbon solutions to deliver things that we already use today. And I touched on our renders and mortars business. Again, they're starting to use now crushed glass cullet in place of cement as filler for their render products. So again, traditional materials that we're using in retrofit day to day. And so we are producing new innovative things for retrofit, but it's really key that we try and tackle the everyday materials that are used in almost every single project. I'll leave it there with a couple of our key principles around retrofit. I mean, there's probably more, but let's make sure we do it right and safely to deliver the right outcomes. You know, there's nothing worse than spending a load of money, time, and carbon retrofitting a building badly. I'm certain everyone in the room will have experienced a bad retrofit project, which has ended up with unintended consequences. We continue to develop new innovative solutions to support the delivery of, make it easier, and continue to innovate through the use of LCA to reduce the impact of our traditional construction products. And that's it.
Thank you so much, Gareth. It's really exciting to see how you're considering like the entire material system and how each material kind of relates to another. And in doing that, I mean, anyone in this room who specifies more than likely has specified some of your products. So to know that there's transformation happening in that space as well is really exciting. Yeah, next up, I'm going to hand over to Rob. Over to you.
Super. Hi, everyone. That looks right, good. Hi, I'm Rob Grover. I'm from the University of Bath. And I'm going to talk about one project today. So my background is as an architect. I'm going to talk about this project. It's actually called Transforming Houses and Homes for Future Generations, but we shortened it to Transforming Homes, which is a bit easier to remember. And I'm going to talk specifically around some of the work that we're doing around using bio-based materials in retrofit, but through a co-design and a community-led lens. And I should say that the project's funded by the Arts and Humanities Research Council. It's part of a big consortium, so it's us at Bath, but also Cardiff Universities, Bristol, Exeter Universities, and a whole series of industry partners as well. And part of the project is we're delivering some demonstrator homes, and we're delivering one set in Swansea, but also another set of demonstrators, which I'll talk about in Bristol. So this is South Bristol, this is Knoll West. This is a series of homes that were built in the 1930s in the Homes for Heroes house building drive after the First World War. in Knoll West, there's 5,000 homes that were built at this time, and there's a number of estates like this across the country. There's about 1.4 million homes. They're of, as anyone that knows their history of house building in the UK, they're of their early, very early cavity construction. So they've all got roughly sort of a 50 mil cavity, and that makes them kind of hard to treat, and it's got some issues which we'll talk about a bit later on as well. And when we started the project, a really big drive for the project was thinking about how we work with these hard to treat homes, but how we do that with bio-based materials and what that looks like. But as the project started to mature, we really started to build into that an idea around community and local-led delivery, what that might look like, delivering that in a tenure-blind way. So a lot of these estates, and Knoll West particularly, is a real mix of tenures. There's private rented, there is social housing, there's private owner occupied as well. But typically, they're often in mixed terraces. So there's a kind of real mix of homes. And how do we start thinking about retrofit in a collective way, in a shared way, and in a way that starts to work on a street by street and neighbourhood basis rather than a home by home, home by home basis. And a big part of this was really bringing the community into that decision making as well. As part of this, we did extensive analysis and extensive surveys of the homes. So we've been monitoring these homes for a year, but we've also measured pretty much everything about the homes you could think of. But I've just picked this slide to show, because one of the things that I think's really come out of a lot of the monitoring we've done is it's not just about how people live in the homes, how people heat their homes, and some of the issues that have been brought about through poor maintenance, but it's also around some of the initial design, I want to say, defects or challenges around the homes. So this shows a sort of dropped eaves detail in a bedroom where there's a sloped bit of ceiling, which is near impossible to insulate. And this is a challenge across pretty much every home that was built in this era. They have a very common detail. This has been a huge challenge for these homes and almost all of them have a kind of area of condensation and sort of mould that collects along there, and certainly the ones we've studied. And one of the really big things that's come out of that analysis is we've done some quite invasive work as well. So these are insulation samples that were pulled out of that narrow cavity. So all of these homes were retrofit with insulation in the 1990s, we think. There's no records, we don't know exactly when, we're guessing. They're all filled with a sort of mineral wool. Oh dear, incredibly sensitive. I'll put that down. It's going to fall off. They're all filled with a mineral wool type insulation. And as you can see, it's come out in various states, but in fact, all of the homes that we've looked at, it's wet and to different degrees. To some extent, you can see at the top here, it's kind of formed tiny little balls, came out almost completely saturated, and we took that back into our labs and we dried it out, and actually can measure the moisture content through weighing it. And so that was a key part of what we did, and actually started to realise that there's some real issues in these homes that are just that no amount of ventilation or mould-resistant paint is going to affect. There's some really key defects in how these have been retrofit in the past that we really need to think about. And as I mentioned, our approach really has been driven by the community. And without the community involved, we wouldn't have been able to develop where we got to. This is an image of a playing out day on the street that we're working on, organised by our fantastic community partners, who are a group called We Can Make, who are based in Knoll West in South Bristol. And they've been really instrumental in galvanising and mobilising this community and generating community support. But one of the things that's really come out of this is all of the residents that are involved in the project are facing similar issues and similar challenges. That dropped eaves detail, the saturated insulation. These are all things that are common across the whole estate, and actually coming together and really starting to have a collective understanding that people aren't alone. These challenges are actually shared and really common in these housing types has been a real strength for the project, but also enabled us to start to create collective and community-based action. And then as part of that, we've really started to bring bio-based materials back into this as part of this narrative and part of this story of transformation. We've done that through a lot of design charrettes. So I think we've hosted 5 now design charrettes with the street in Bristol. We're taking a very co-design approach, working directly with the materials and with bio-based materials. And one of the great things I think about using bio-based materials, as the other speakers mentioned, is they're kind of nice to hold. You know, you can hug them and squeeze them and squash them, and they don't kind of give you skin irritation and, you know, make your eyes itch. They're quite tactile, and that's been a real positive, I think, working with the community. There's something that's really tangible and can be really understood, and is understood as this sort of non-toxic and, I guess, a safe material to use. And putting materials at the heart of these co-design sessions has been a real positive. That's my last slide. What this has actually meant and where we're up to now, so about 1.5 years in, this has led to a whole range of interventions which we've worked through the residents with, including how we're going to extract some of the failed cavity wall insulation, how we're going to use bio-based EWI, but also working with We Can Make, who actually also operates a small-scale community MMC facility, actually start to build bio-based extensions to spatially transform the homes as well. So how do we think about retrofit as being something more than just improving energy performance of homes? How does it become about changing the spatial performance and the ability of these homes to operate effectively into the future? So I think I'll leave it there. Thank you.
Thank you so much, Rob. Yeah, one of the things I really love about this project is that it ties so many strands together. It's got like really technical, super nerdy testing and details and woofy modelling, and then it combines this co-design, and it doesn't keep them separate. It really engages the community with what this means for their homes. And I just think, I can't wait to see what happens next with it. Now I'm going to hand over to our last speaker of the day before our panel session, Victoria.
Hi everyone, so as Rachel said, my name is Victoria. I'm from EWI Pro. EWI Pro are specifically an external wall insulation system designer and manufacturer. So we've got some basic EWI principles that I've put together here. So our systems are made up of finishes, which could be render, paints, brick slips, things like that. Adhesives, insulation, beading, mesh and fixings. We produce and supply all of it, so it's a one-stop shop effectively. It's a kind of a solution intended initially for buildings without an internal cavity, but that is not to say that that's all it's for, because it does also supply a kind of a facelift for buildings as well. It improves the thermal performance and the appearance, as I just said, and it is suitable for use in both residential and commercial sectors. So we're working on a lot of research at the moment so that we can start going more into the commercial buildings. I'll touch on more on that later. But the reason that EWI is so important is that this fabric first principle, and it comes into things like retrofitting. If we don't prioritise making sure that buildings have this kind of nice thermal tight like envelope, then basically any heating solution that you do put in there, the heat will just come straight back out. So that fabric first principle is very important to minimise the heat loss, so everything can operate optimally. High quality insulation, especially if it's breathable, it'll also stop things like mold and condensation, damp and things like that. So it will also make sure that any occupants of the buildings can have a much healthier lifestyle within the building as well. And it is one of the best ways to lower your energy bills, which, as we know, is a big problem for us right now. These are some of our systems. I won't go into all of them because obviously there's quite a lot there. But the ones I will touch on are the ones at the bottom, the new and innovative ones. So we most recently, right in the middle, we've got the new A1 rated. This is one of the things we're doing to make sure that we can get into the commercial sector, so that these commercial buildings can be retrofitted to make sure that they are, performing thermally. So some of the innovations that we're looking at, we're really just launching our lime range. Now, we like to make sure that our products are as eco-friendly as possible. So lime is actually produced at much lower temperatures than cement. Now, depending on what study you read, they can emit up to 97% less CO2 during manufacture. Obviously, numbers do fluctuate somewhat, but there have been studies up to that number. As lime sets as well as it cures, it does also sequester CO2, which means that it is taking in more CO2 as it's basically being used, and it does store heat and it stabilizes internal temperatures. It's also very breathable as well. It's used a lot on older buildings, so that it makes sure that they can still be like heritage buildings and things like that. They can still be looked after. Wood fibre is another one that we're just launching with at the moment. We were really, really intrigued by how these can also sequester carbon. So between 160 and 260 CO2 equivalent per metres cubed of board. We found that really, really useful. So not only is it going to make the home itself much more thermally efficient, it also sequestering carbon as it goes. Now, some of the other speakers have also touched on this kind of circular economy. 100% of raw materials are used in the Styco wood fibre insulation boards that are going into our new systems as well. And it's another one that, because it's breathable, temperature and humidity, it can be managed much more easily within the house. So it makes it much more energy efficient, ultimately reducing the amount of carbon used. Rockwool as well is something that we've been using for a long, long time. This isn't new in our systems, but they are, as a company, making steps to make sure that their products are getting more and more ecologically efficient. So they're making sure that they are using renewable energy to power a lot of their factories and a lot of things like that. I won't go through all of it because I'm very aware of the time, but I did want to put all of the information there. So one thing that we're keen on at EWI Pro is actually evaluating the suppliers that we use to go into our systems, which is how we know all of these different facts about the different items that we're using. So we like to basically do our own evaluation based on ESG principles, but also effectively based on ecological principles, how they've designed things, how they've chosen their own materials and things like that. I would be remiss if I didn't mention Inca while I was here. We are here on behalf of Inca. They've asked us to step in for them. Inca have been a major player in the EWI industry for a long, long time. One of the main things that we feel that they've done is they kind of closing the green skills gap. They led the first ever creation of the NVQ equivalent qualification specifically tailored to EWI. That kind of helps a lot more people get into the industry, specifically EWI, which is so used in retrofit to make sure that homes that maybe don't have a decent internal cavity can still be insulated. They are also really big players in dealing with the government to make sure that funding schemes like Eco4, GBIS, SHDF and things like that can be launched and can be effective. And make sure that they're run properly. They basically, Inca are one of the key players in the EWI industry. One thing I want to focus on at the moment, this is Howgate Close. Full disclosure, this is a new build, but the reason we want to highlight this is because it does use a whole system approach. It doesn't just focus on one thing to do with energy efficiency, i.e. EWI is part of it, but they're using all of it. And obviously that is such an important factor in retrofit to make sure that we look at the whole system, the whole building. So it's actually won a few awards, but one of the ones we're most keen on is the Environmental Impact Award 2023 at the Inca Awards. So the whole ethos of the building, they started with a fabric first approach. And then they also looked at other technologies like solar and heat pumps and things like that to make sure that not only was the home really, really well insulated, but it had the right technology to power it once it was ready. Once that shell was built, the right things were put in place. These are actually 9 purpose-built homes for social housing. They were built on a relatively low budget, and they used 230 mil EPS to insulate them. Now, so this is obviously about this wide. Now, EPS, obviously, it's got a bit of a bad name, but the insulating properties of it are pretty incredible. So that's why they chose it on this project, also to keep costs down. Now, there is a few natural design strategies that they used at this place to make sure that they were making the most of it. Things like the passive solar gain, so making sure that all of the windows were south-facing. So in the summer and in the winter, they were still getting the heat in. And then the cross-ventilation as well, making sure that there was enough breathability going through it. There are a few other things, but I think that those are the main things that would be useful. Now, the results from it were pretty shocking in a good way. So as you can see, the EPC rating of 143A, which it beat every kind of hope that they had for it. And they managed to do this with a construction cost that is really not that much more than a normal build. So it basically, the reason that we find this so exciting is it's a real world example of how a few different technologies all put in the right place, combined in a proper way, can show that post-hydrocarbon living, it genuinely is possible. So most of the tenants, they either gain money from the grid, or they cost less than £1 a day to run this home. It's actually incredible. 6 of the 9 have no heating systems whatsoever and maintain an ambient temperature between 18 degrees and 22 degrees throughout the year. So we find that pretty incredible, which is why we do want to shout about it. But as I said, every single thing, we worked with all of the designers on this. This wasn't just an EWI project. We worked closely with every single designer, all the solar, there's even EV chargers there. They were all part of the design process. So it is a real key cross-collaboration kind of case study. And that's everything. So thanks for listening.
Fantastic. Thanks so much, Victoria. We're going to do a little bit of rearranging up here and invite the speakers up to the stage, and then we're going to get into some panel discussion. So do have a think about your questions. I'm moving this to the side, right? Okay, thanks very much. So maybe I'll kick off with an initial question and then we'll come to the room. But I know that sometimes we think about the strategies for lowering embodied carbon or lowering operational energy use in silos, but many of you talked about the circular economy and how that's a sort of critical component of reducing carbon emissions through retrofit. So I wondered if each of you would like to talk a little bit about how your work or your organisation is working within the circular economy.
Thank you, Rachel. Yeah, so circularity I think is really going to be key for our business going forward. We've been using it as a tool to recover resources for quite a while. Some materials are much easier to do it with than others. Glass, as I described, is sort of a win-win, really straightforward. All we've got to do is get hold of it. So if any of you've got any, we will have our chap Richard is literally walking around London today looking for glass coming out of buildings. So, but there are other products like plasterboard, which there's vast quantities of. It's much harder to do. And actually, we might drive up recycled content. In some cases, we might increase CO2 because actually we're moving material around, we're processing it in a different way. So I think it's going to be really key because we're going to run out of resources one way or another. And we've got to leverage I think we've been referring to it as a sort of the magic mine, which is the city, because it just keeps filling back up again, not like the ones under the ground. So it's going to be really key for us.
Yeah, I guess I just find the whole kind of concept of the circular economy quite like an exciting opportunity. And I guess the challenge is just kind of changing people's mindset. Like for so long, they've just been used to kind of like get the stuff, do the job, finish, walk away without any kind of consideration as to, what is going to happen in 20 years' time when somebody comes to take it apart. And yeah, I find it really fascinating. All the concepts of like bolting stuff together, instead of nailing it or whatever. And, there's so many practical examples. I think I've already spoken quite a bit about our own business and the fact that we use basically all recycled materials. So yeah, I'll just pass on.
Is that working? Oh yeah, there we go. There, right. So I can talk a little bit about some of the work we've done in Bristol. So circularity is a key part of the project, both in term, but sort of thinking of this in a sort of whole range of different ways. So that includes one of the pieces of work we're doing at the moment is actually looking at regional and local materials and how they're built into a circular economy. We're looking at local delivery as part of that. So thinking about circularity as a sort of economic concept as well. So how do we use for example, retrofit investment to actually build social value at the same time? What might that look like? So how can we, rather than funding about retrofit being just about delivery, how can it also be about building skills, building labour, building local capacity, but also critically, and I think in some of these communities, inward investment within those communities as well. And then I could talk about very briefly some of the other work we've been doing with We Can Make, particularly around sort of really small scale circularity and community-led circularity. So one of the things we've done is we did a feasibility study last year around an urban mine. And so how might a small scale community organisation actually build their own urban mine of materials? What might that look like? How do we join together a localised network? How do we store these things? How do we move them around? What can we actually collect and what can't we collect? So that's some of the work we've been doing, but that's at a really sort of small scale, community-led approach to circularity, I suppose, rather than these kind of bigger ideas about recycling, I suppose.
So at EWI Pro, we do a few things kind of internally as well as finding new products. So I touched on the products that we're looking at in the presentation, things like the wood fibre boards, which use 100% of the raw materials and things like that also sequester carbon. But then we also work with the suppliers that maybe whose products aren't necessarily so ecologically efficient. So things like EPS, we work with our supplier, we have an agreement with them that any offcuts from our installers, any damaged boards, things like that, they take them back. They actually use all of it to go straight back into the polystyrene chipper and they remake it into another board. So there's no wastage there. We make sure we've got those agreements in place. But also by doing the things like the supplier evaluations that we do internally, it makes sure that all of our suppliers and manufacturers, they're all held to account for how they deal with things like waste and how they deal with their energy internally. So we like to make sure that we're not only trying to create more efficient systems that are better for the planet, but we're also holding our suppliers accountable for what they produce as well. So we like to do a whole system approach effectively.
I think it will. Okay. I'll just use that. Sorry. So in terms of our project, we're thinking a lot about whether a project is designed for a long life or a short life. So, for example, if it's designed for a short life, we might consider incorporating bolted connections or standardized components that can be taken apart. Whereas if a building is designed for a long life, we'd consider kind of long-lasting materials and designing for durability, good detailing. Alternatively, if we're demolishing a building, I think we would think about doing something like a demolition audit so that, for example, if it's a steel frame, could all the steel be reused? Or if it's a concrete frame, could that concrete be crushed and recycled and used on other projects?
Amazing, thank you so much. I think that what this really highlights is the different roles that each person in the supply chain plays, and also what we expect from one another. Like, really interesting to hear your example, Victoria, of you as a system provider then influencing the manufacturer, and how all of those interrelated relationships work. And I think the circular economy is very much part of that, driven by relationships a lot of the time. I'm wondering if anyone in the audience has a question. Would you like to put up your hand if you do? We've got one just here.
Should kick in, yeah.
Yeah, just linked with the circularity concept and investing in materials in the building, and you should know the life cycle of it. I'm interested in the mineral wool that failed in the Bristol project, because that seemed to fail on every sample. I'd like to understand, because everything's kind of moving towards mineral wool on a large scale because of the fire rating. We've got Saint-Gobain here as well. Is that kind of a common thing that you've seen before, or what went wrong there?
Yeah, so obviously we can only talk about as a good researcher, I can only talk about the homes that we've looked at. I wouldn't want to speculate on the rest of the UK, but I think in the instances we looked at, there's a sort of number. So it's not, in that instance, I would say it's not the material itself that was the issue. It was the nature of the installation. So we've got very narrow cavities. When they were built, and over time, those cavities, and when they were built as well, weren't maintained particularly well. They're full of bits of, we've had to peek down a few, they've got bits of rubble in, there's kind of, as you can imagine, there's mortar snots and all kinds of things down the back of there. So you've got these very narrow cavities, but also you've got a situation where over time, external render hasn't been maintained effectively, or in cases where there isn't render, bricks haven't been repointed, and so over time you just get ingress into that cavity, and essentially they're so narrow, we just think there's nowhere for the moisture to go, and it just basically builds up within that cavity. So in that sense, I guess it's not the material itself that's the issue, it's the actual design of the cavity, and whether actually, given the nature of these homes, whether actually retrofitting cavity wall insulation was the right thing to do at the time.
it's probably worth saying that at the National Retrofit Hub, we're going to host the University of Bath in a month or so to do a webinar on this topic. So please sign up to our newsletter and you'll get an invite. I think as well, one of the real dangers here is that these homes were achieving, an EPC of C or something like that, but obviously not achieving it. So theoretically not eligible for any grants, but in dire need of work. So there's sort of miscalculation that happens because of not taking into account the failures in those systems as well.
Yeah, and that's definitely true, and I don't want to get into the challenges around EPCs, but that's absolutely right. I think the other thing is they'd also gone through years of maintenance or fixing some of the problems that were related to this, so, damp and mould, but never ever fixing the root cause. So in this case, the council were just on a constant maintenance cycle, just essentially every couple of years, coming back and repairing, repainting, redecorating areas of these homes to remove mould. But
We've got another question just over here.
Hi, I was just waiting for an opportunity to jump in. Now you've mentioned damp and mould, and Arab's Law comes into force in October. We've developed a platform for detecting damp and mould, which is to be beta tested. So the leaflets is outside there, and it's open to be beta test for existing and retrofit buildings as well, because that can be an issue going forward with retrofitting as well then. So I'd ask anyone to share this with any of their colleagues to sign in and beta test it, and we welcome your feedback for the industry.
great.
Thank you. And I guess as well, when we're talking about carbon and materials, one of the things we need to make sure we do is get things right first time so that we're not redoing them again. I know EWI Pro, you've got lots of processes in place to ensure good quality installation, but I don't know if any of you want to touch on any views you have on the sort of quality or getting the specification right in the first place as a mechanism in itself for making sure that we eliminate future embodied carbon emissions. If anyone has thoughts?
This is not so much of an overview, but maybe just going back a little bit to that example. The purpose of the cavity obviously is so that if any moisture gets in, that the water can run straight down and out. So if you are going to fill it with any kind of insulation, then using something like a polystyrene bead, which if water gets in, it can just go straight down, is the solution. And I think for decades, really, a lot of builders knew that fiberglass insulation was not ideal for that application, but they just kept using it anyway. Fiberglass, has got a really good role to play in like lofts and so on. But, each of the strands, if you look at it in detail, each of the strands is a solid little fiber, so that the moisture doesn't actually absorb into it. It sits in little droplets between the strands, and so moisture eventually will track from the outside across like a little bridge. So I would say that's just like, although it can be a good product in certain applications, they were just really using the wrong product in the wrong situation. And there's still many examples of where builders are using products because they're cheap, even though they know that they're not the best product for that particular application. And I don't have a solution. I don't know what the solution to that is, but it's certainly something that's going on. And if we were to sit here in 10 or 20 years, I'm sure we'd be looking back to things that are going to houses right now, causing problems as well.
Any other thoughts from the panel or other questions from the audience so far?
I mean, I'll just... Oh, sorry.
Oh, no,
I was just going to add a couple of points to that last one. I mean, I think you're getting into the big issue around retrofit is, we're going to do a load of work and it's going to fail, and then we're going to redo all the work, and it probably will fail again unless we properly understand the building that we're trying to retrofit, diagnose it properly, come up with the right solutions, and actually make sure it's installed properly. I mean, that was one of the big drivers around that work we did at Salford 10, 15 years ago, and it was almost too early, really, everyone's just more concerned of let's whack some insulation on the building without really thinking about what we're going to do about the ventilation, what we're going to do about this and that, and what we're going to do at junction details, interfaces between elements. So I think I'd just advocate that you look at the standards involved with doing proper retrofit and really understand the building typology that you're trying to improve and come up with the right solutions for it.
Thank you. I think we've got a question. Sorry, catching you off guard there.
No problem at all. Sisaltech touched on this, but how does everyone else contend with the history of the UK housing stock? I think we've got the oldest housing stock in the world, certainly in Europe. And I was wondering how you kind of promote retrofit when you're kind of contending with the aesthetic sensibilities that we kind of live in with, I mean.
Premma, I don't know if you've got some thoughts on, I know a lot of your buildings were the sort of non-beautiful kept buildings.
I think it needs to be approached in a different way. I think if you're looking at an existing building on a site, you have to say, you have to think outside the box in terms of design and what you would do with that building, rather than thinking, what would I do with this site with another building, and try and merge that into the building that you have. So I think it involves like a lot more kind of thinking outside the box and just thinking from more of a design point of view about how you're going to use the existing, rather than comparing it to what you could do if you were to knock it down and do something else.
I think as well, we're quite excited about the idea of what if we sort of looked at every building as if it was a heritage building, as if it was special, and that we had to keep all of it and start from that position, because the sort of embodied heritage of these buildings is huge, and then go from there. And I think a lot of the time people see heritage and retrofit as being sort of at odds, but actually I think if we consider buildings in this holistic way, where we understand completely how they work, the building physics of them, and then we use the materials that are suitable, we'll end up with much better decisions being made, and also hopefully lasting stock and keeping the sort of built heritage. But yeah, I don't know what else anyone thinks.
Yeah, I was, thank you for the question. I was also just going to kind of mention that if the date keeps varying for when we're supposed to hit net zero by, but, whenever it is, whether it's, 2035 or 2040 or 2045, or whenever it is in there, if you were to look at what buildings will exist then, about 80% of them already exist now. Probably only 20% are going to be built between now and then. So, in other words, pretty much all of the buildings that we have now will need to be insulated. So between now and then, we need somehow to properly understand how all those different buildings work, and to kind of categorize those archetypes. We get phone calls all the time from homeowners who are convinced that their home is entirely unique, which, it is, there's maybe a dozen roughly different kind of archetypes in the UK. And I think we probably do need to move towards a position where we kind of, have a more or less a rough kind of guide of how to approach each of those in a kind of sustainable and effective way, basically. I also I missed out one little thing, going back to our previous conversation. I should probably also have said, we also wouldn't recommend our product in an application, because our product is essentially absorbent. We wouldn't put it in a cavity either. So we probably need to move also to a situation where manufacturers are open in saying, actually, we wouldn't use our product for that, but we would use it for that.
Thanks. I think Rob's next.
Yeah, I was just going to pick up on that point about our built heritage, but I think there's something, there's a real opportunity, I think, with retrofit and a retrofit agenda to really enhance our built heritage and also the quality of our built environment. And I think that's where thinking a bit more collectively and a bit more holistically about what retrofit could be really starts to build that. So if we think on a house by house basis or dwelling by dwelling basis, I think we end up with this kind of piecemeal approach that doesn't really start to enhance collectively the quality of our built environment. If we start to think, actually, how do we transform a street and what does transformation look like, we can really start to really celebrate our heritage and really start to develop that. So Bristol's a great example. These homes were modelled when they were built. They were modelled on, the estates were modelled on garden cities. The homes were initially modelled on principles of the arts and crafts. A lot of that's really been lost over time, but suddenly retrofit and transformation really gives us an opportunity to start to reaffirm some of those design principles and rebuild value and quality back into the built environment. So I think there's a massive opportunity there. In some ways, it's I think it's a huge chance to really improve actually the quality of everything beyond the homes itself.
Yeah, I agree. So you mentioned dealing with it holistically. I think that's kind of the point. So when we see like a building that needs to be done or retrofitted, it needs to be done wholly, like how it's going to be used. But it's also about trusting the designers behind each aspect. So one of the reasons why our case study, Howgate Close, was so successful is because we trusted every individual partner to do what's right by their product, basically. And now sometimes there was some logistical issues in dealing with so many people because there was quite a lot of companies involved, but it did come together collectively. There was lots of meetings, there was lots of site visits from all different technical teams, but it did come together and it did show that there isn't one right solution. Everything has to go into it, all has to be quality, and you can't really go too cheap on anything. You have to make sure it's built properly the first time.
Any other questions from the audience? Yeah, we've got one just here and then another one there.
Hi, I was wondering if anybody got any thoughts about how we get the best practice in materials and detailing through to ordinary jobbing builders, because it's, what is it? I think it's Aileen from Beaver Box says something like 95% of people in the construction industry work for a company with fewer than 5 employees, and we've got 4 million social housing. There's another 22 million that we've got to deal with, that the majority of which are privately owned or they're privately rented. And they're not going to be done by the sort of big construction. They're not going to be done by the mighties and things like that. They're going to be done by local builders. And the ones that I see are still putting up cavity walls with partial fill insulation across the road from me when they're building an extension. So it seems there's a long way to go with them. And I wonder if anyone's got any thoughts around that, really.
So there is a big green skills gap, which is something that EWI Pro are really keen on kind of bridging. So we're involved with quite a few schemes. So we've been involved with the new NVQ for EWI that's been launched. We also have our own training centres that are completely free for anyone who wants to use our products to come and learn how to use them properly. It's a big, I totally agree with you, you kind of have these one-man bands go around, they're general builders, they think they can do a bit of everything. But we do need to bring up the standard of education. And I think a lot of this is going to be useful when it comes to how we've changed things with schools. Now you have to go on to either college or apprenticeships or things like that. These things are helping because there is more courses now with regards to retrofit because it's such a growing industry. So I think there is a lot more education coming into it at the moment. I think obviously there will be a transition period, but I think that kind of idea is being phased out slowly.
Anyone else want to add?
Yeah, so I think there's massive need for training, but I think equally there's a big responsibility on manufacturers to supply more information about how do we install these safely, whether that's guidance documents, videos. We can offer as much practical training as we like. If people don't want to come to it, then it'll be a real challenge to get them to do it. So it's how do we make that information more accessible, easier to deal with. I think there's also some things proposed. I don't know if anyone's had the pleasure of the UK Green Paper on construction product safety reform. There's an awful lot in there which is sort of trying to drive us towards ensuring, making someone responsible at least for proper installation of construction products. And I'm not sure exactly how some of those things are going to work as yet, but there's some ideas in there. And it'd be interesting to see how that goes. But I agree it's a big issue, and the best we can do at this point is offer training and provide information. It's still relying on people picking that up and doing things with it.
Yeah, the other thing I'd add is I think we're exactly right. We have a huge number of I think individuals and very small companies working within communities. But I think that can be a massive asset, and finding ways in which we can start to mobilise that asset and start to bring people, and again, sort of everything I've said, really, I guess that idea of collectiveness, how we can bring people together to start to share skills, share knowledge, build education, but I think also critically share risk as well. I suspect, I don't know, but a lot of the way, the reasons things are done like they've always been done is because it's the lowest risk way often to do things, because that's how people understand. And actually doing something new, especially if you work on your own, is challenging. It's really challenging. So ways in which we can find ways to share that risk, I think, and collectively build innovation into what we're doing. I think that's a key part of what we need to do. But critically, mobilising that sort of latent workforce and those latent skills to do that, because I think it's in some ways it's sort of all there. I think we probably need more people, but it's all there. It's just, I guess, mobilising it and the right direction.
I should probably also mention that we launched a white paper on Monday, which is all about the policy needs for creating a strong national retrofit workforce. And it's got asks in there from the government, but it's also got actions that combined authorities, local authorities, contractors, training providers can take. And there's 10 recommendations, but they span from everything from the sort of scale of the length of the strategy to embedding building physics in all of construction training, the role of apprenticeships, the role of SMEs and supporting SMEs to get into the retrofit sector in a way that allows them to upskill themselves, and also the importance of social value and procurement. So please do check that out if you're at all interested. I think we have time for one more question, which I think we had one just here.
Yeah, thank you. I actually have a similar question on retrofit housing, because I wonder what is the biggest barrier so far to actually retrofit them, because as you mentioned earlier, like how they get access to all these advanced measures, and apart from that, how about the cost and financial side? Do they really have enough money to really start the retrofit? And I'm aware that there are some government funding, and I wonder how it's actually helpful, because is that really enough?
So does everyone have a what's your sort of barrier that you want to tackle on retrofitting at scale?
So one of the barriers is that it's really disruptive. If you want to, properly do a deep retrofit, it basically means taking all your stuff out the house, leaving the house, and essentially ripping most of the interior out. So as a result, it tends to only happen when people move house, and people don't move house that often. So there's definitely a barrier there.
And I guess that's about finding the right trigger points for when you can do work and having a retrofit plan in place. So it's almost like we know what we need to do when we have the opportunity to do it. So like I'm doing a kitchen extension, what else can I do right now?
I think if I was to pick one barrier, I think trust. And I think trust in the system and trust from communities and households to actually do works. And you've mentioned the disruption. I think that's all part of it, but I think there's a lot of perceived risk. There's a perception of disruption. There's often, I think, a lot of mistrust around building work and what that might mean. And I think ways in which we can start to readdress the balance between actually trust and belief that this is something we need to do versus the risks and the challenges of doing it, and start to readdress that a little bit. I think that's where actually we can get a huge change and a huge shift. That would be my one big challenge, I suppose.
I wanted to finish on one last question for all of you, really, which is sort of speaking to this audience that are here today. Is there one thing that you would ask them? Say they're starting a new project in whatever role they play. What would you want them to reconsider when they're approaching that product, to think more holistically about embodied carbon, whole life carbon, ecological impacts? I don't know, Premma, do you want to start?
I would say it's about bringing lots of different professions together. For example, architects, structural engineers, facade engineers, surface engineers, and thinking about the kind of sensitivity of all elements of embodied carbon and operational carbon in terms of whole life carbon.
Yeah, I would second that in a similar way. Rethink project managing yourself. Get someone in who understands how to deal with several different suppliers and actually understands a lot of the technical jargon, because speaking just from an EWI perspective, there's a lot of jargon involved with that. Looking at solar panels, there's a lot of jargon in that. It's so much to understand. An experienced project manager really can make the difference for a project.
I would encourage everyone to think beyond the project. So what more can you do with your retrofit? How can it be a catalyst for change in other ways? How can it build social value? How can it create something more than itself? And then I guess the other aspect linked to that would be think about all of the co-benefits that you can extract from that retrofit. And we talked about, thought about bio-based materials in terms of low embodied carbon, but also we've not talked about so much about the health benefits or the comfort benefits or the investing in your local economy benefits. How do we think about this in a much wider way that starts to catalyse actually sort of much more transformative change?
I think my request would be to get people to try and, although it's hard, try and think about the kind of practicalities of some of their material choices and not base everything on numbers. Obviously numbers on data sheets are important, but to take an example from like the insulation world, like sometimes people might choose a particular PIR insulation because it's got on paper the best thermal performance, but in reality, in the real world, when you come to fit it, a lot will depend on how well it's fitted, on the quality of your workmanship, because like clearly it's stating the obvious. If you've got gaps around the edges, you're not going to get that performance that's written on the bit of paper. And I think, a lot of people don't take the time to kind of think, right, how will this actually translate into the real world? And that whole kind of issue of the performance gap that we touched on earlier, where we had theoretically good EPCs, but in the real world they're not. So just thinking through all those practicalities to ensure that you don't get a big performance gap.
It's quite a hard question, if I'm honest. And it really depends what kind of retrofit project you're talking about. I think, as was just being said a minute ago, if you're talking sort of large-scale potential retrofit projects, local authority level, think about, I always think that your question is very valid. Cost is a challenge, always a challenge. And in the fear of not being able to do everything, people just do something, and that something doesn't necessarily always end up being right. So I think if you're dealing with trying to define a budget for a large-scale retrofit, think about those co-benefits. I mean, I think there was quite a nice study years ago in Oldham, which I'm not sure how the methodology worked, but for every £1 spent on the retrofit in that town, the local NHS saved £3 because people were healthier and weren't going in with colds and other health issues. Again, methodology to be tested, I'm sure, but think about how else. What are the implications of not doing it, and how do I make more funds available to make sure that we do it right and reap those benefits? I think if you're talking around small scale retrofit, someone doing their house, if you can't afford to do it all properly, just do a couple of bits properly, and make sure you think about those unintended consequences and what will be the outcome if you just throw solutions at it without having a proper strategy.
I was almost worried we were going to get to the end of a session on retrofit and not say the phrase unintended consequences. So thank you for that. All great responses. Please join me in giving our speakers a massive round of applause. So I think we've got half an hour. If you want to go look around the exhibition, mingle, get to know each other, ask speakers questions that you didn't get a chance to. And thank you very much for joining. It's all going to be online, right?
It is recorded, so this session will be available for you to look back on. And next week we've got a panel on innovation. So we've got Innovate UK and Connected Places, Catapult, and others speaking next Wednesday. So do check out Building Centre website for that. And thank you, Rachel.
Thank you, Laura.